Hey guys, welcome to the next lesson. SAS Programming. This time we're going to introduce SQL. So it's a very exciting day today. SQL is a very powerful and important tool within SAS that you can use to merge, analyze, and connect data. So if you're familiar with SQL, you know it's actually used in many different applications. It's a standard for which to query and to develop reports for any kind of database. You can use SQL in Microsoft Access, DB2. MySQL is a freeware, shareware database that's very popular in the professional world. And most of what you can do, what you are able to in terms of being a powerful and useful SAS programmer is done using SQL. So let's get to it. SQL is an acronym. It stands for Structured Query Language. What do we mean by query? A query is the important word in this acronym. So let's explore this word a little bit deeper. So the word query, if you look at it, look up the word query in any sort of dictionary or encyclopedia, a query is a question. And the word query is usually expressed as to an official organization, meaning query, when you say the word query, it's a very formal word used when you're using a very formal method of speaking English. It's just, query is just another word for question, really. But if we're to look at the word query in some more of a technology computer method, a query is basically a way in which to pull data. It's an inquiry of a data set or a database computer system whose output is readable to the user. So thinking about a database or computer system where the data is stored in the computer in electronic signals or ones and zeros, in order to create and pull that data out into a usable form, you would query the data, and that's how you use the word as an adjective. Query the data in a system in order to pull it out and make it readable, develop a story or a hypothesis or conclusion with that data. The key to building queries is first understanding query mechanics. And query mechanics refers to how queries are executed. So you think about SAS. Basically, from here on, we're going to break out all SAS commands into two kinds. There's the normal SAS commands, which you can go back to lessons 1 to 4 and review. And then there's SQL SAS commands, which are used specifically for the data functions, the real reporting functions. In order to know what queries are due, we're going to look at query mechanics, because query commands run a bit differently than normal SAS commands. Query execution. So query execution in any computer system, whether it's SAS or Microsoft Access or MySQL, has these overall big picture 4 steps. First, when you run a query, the first thing a computer system does is it checks the permission and the syntax of the criteria. And then the query is transferred to something called a query optimizer, where the query is broken down into more of a machine language that the computer system can execute in its own way more quickly. And then what the optimizer does is it also determines the order in which to connect the tables and picks the execution plan. Number 3 is a very technical step which the user doesn't need to be involved in. It's all automated. The resulting set is then returned to the user, unless, of course, the query command has some sort of error or there's some sort of problem with the source data. So the best way to avoid any sort of syntax error in your query commands is to follow lessons like these and learn some of the basics, some of the foundations. So if you're making a database in your local computer, or you're using freeware, Microsoft, one of the Microsoft products, your system might not have pre-execution steps. But if a lot of you that I meet and a lot of the reasons that I make these lessons is that all of you want to learn SAS and you want to learn SQL to help you at your work. So you're using SAS and SQL in your business. And if you are, you might want to take note of these pre-execution steps. So before the query is executed, these steps are followed by the computer before. Number one, the system's going to check if you have permission to execute the statement. Then the system's going to check if you have permission to access the data, and then is the query statement syntax correct according to your corporate system. And that's it in terms of the understanding the overall concepts of how a query works. We're going to look at one specific command in SQL SAS, and that's the select command. So we're going to run our first select command. But what do we mean by select? So the select code word is a command, a SQL command. It's not a SAS command. It's a SQL command that it represents a specific kind of movement of data with your SAS programs. So SQL commands are constructed with command pieces, and these pieces are called clauses. So what I mean by command is a complete sentence which the computer understands as one action that pulls the data. But these commands, in order to build a whole command, you've got to understand the pieces, the clauses. There are a total of 5 different clauses you can use with the select to build the select command. And I hope this doesn't get too confusing, but select is a clause word and also a command word. And you'll see what I mean. This concept will get a little bit easier once I explain it. But the thing about the word, when you type the word select in your SQL SAS command, take in mind that the SQL clause is mandatory when you are executing any select command. So without the select clause, there's no select command at all. 5 select clauses. We looked at those before. We'll look at them again. Select, from, where, group by, order. So you can use all 5 of these to build your command. All 5 clauses can be used if necessary, but the reality is, however, the most common use of a select command, it only usually has 3 clauses. Select, from, and where. So we're going to, in this lesson, we're only going to focus on these pieces. Actually, we might not get to the where clause, because you can actually build a select command with just the first 2. So let's look at an example. Let's run the following SAS command. Select star from artists. Do you recall the command? I'm just going to create a new project here. I have not yet opened my SAS, so I've got to set that up. For some reason, it's being nice program. There we go. Here's our SAS. Brand new, fresh window. If you remember from lesson 4, we covered loading data that's embedded directly into our program statement. And for the sake of ease and efficiency, and for whatever system however your version of SAS is using at home, we're going to use the data lines combination that we learned in lesson 4. So let's open a new program, and we'll just review that really quick. Create a fresh new program statement. And if you remember from lesson 4, the data and data lines command has 4 pieces. So data is how we're going to start the program. I'm going to go through this really quickly. I've got all caps on though. So data, and all the folders, all of our tables we want to put into the work folder. Anything in SAS, I mean, you can create your own custom folders, but the work folder is already there, so we're going to keep using it. So the name of the table is actually artists. It's actually plural. And then we go use the code word length, and the next code word is input, and then the next code word is we're going to put it at the beginning. It's called data lines. Data lines. And I think data lines, I'm going to put a colon here. We're going to put a colon, or actually we're going to use semicolons as how you end the lines. For lesson 5, we're only going to use the artist table. And if you recall, there are 1, 2, 3, 4, 5, 6, 7, 8, 10 fields which comprise this data. I'm going to put it right here. So we're going to input all 10 fields in order to create this table called artists. And then in length, going to put these fields, and for every field we're going to specify the field length. And you notice that after the field sometimes there are dollar signs, sometimes they're not. The ones that don't have the dollar signs represent numbers, and the ones with the dollar signs represent fields with characters. So I'm just going to specify very quickly the size of each of these fields. Date established. I'm going to put this on a new line. Oops. 8. And then the show fee, which is a number, is 6. Manager name is 25. 25 actually. Email is 40. And the artist, the address city is 25. Zip code is 7. So just double check to make sure we have numbers after every column, and it looks good. And then after the semicolon, the data lines, we're going to paste all of the data. Oops. Just all of the artist's data. Right here. We can run this and just test it to make sure that we create a table. We haven't started programming in SQL yet. We're just creating our data and making sure that we're uploading a table. Oh, we have an error. So let's check out that error. Syntax error expecting one of the following. Do we have an extra space? Yeah, I put the number and the $ in the wrong order here. So this has to go here. It always helps to run your programs intermittently rather than program a whole thing and run it once, because you want to check your errors. Write your program in pieces and then check each piece. There you go. So these are musical artists. We're going to pretend that you are a talent agent, and you have to use the database in order to do your job. Select artists, sign on new artists, let go of artists who are not selling or performing. And that's sort of the theme of all of these lessons here when we're learning SQL. So now we have a table. We can go to the next line and start programming our SQL. So if you notice in our data command, if you remember for lesson 4, our data command is also like a container that holds 3 other commands: the length, the input, and the data lines. And so we're going to use, we're actually going to use the data command again. Actually, no, we're going to use the proc statement, because within the proc statement, we can create a proc SQL container. And in the proc SQL container has all of the commands for SQL. So that's what we're going to do. We're going to start typing proc SQL and then colon. And at the end of this, we want to run it. And in between the run and the proc SQL, in that container space is where we can create our SQL statement. We want to create a new table in order to view our artists. So we're going to use a create table command. We want to create the table in work. And we're going to call it artist view list as. And that's it. Those are all the normal SAS commands. After the as is where we start using SQL. And our SQL command is going to be really, really simple to start. Because what we're going to do is all we're going to do is select star. Star represents all the fields, and from artist, or artists is the name of the table. So if you recall, if we need to reference the table name, it's right here. It's actually artists, plural. Select star from artists. I'm actually going to use capitals. Select star from artist star. Actually, we're going to go to work. We're going to specify the folder and the table name. And then we close everything off with a colon. That's our complete command. If we run it from the start, it's going to recreate, rebuild the table artists, and that's okay. We can do that. So what you can do is you can create more than one program window or program module and name them. And if you already run your data lines combination command, you only have to do it once. But for the sake of simplicity, let's keep everything in one program window and run everything from the top to the bottom. So now you see that we have two tables. We have one called artist view list and one called artists. You also notice that the tables are actually identical, because what we've done is we have let me just show you both tables first. So here's the table that we created with the data lines commands. And then this is the table that we created with the SQL. And they're identical because we used an asterisk to identify all the columns, and we did not use a filter to cut down the rows. So we're looking at, this is think of the first table as a table that's hidden to us that we can't access. Excuse me, and the second table is what's viewable. So they're identical because we didn't put any filters in our SQL statement. So the purpose of the SQL statement is to enable us to use filters and different options in order to view the data in which you want. Because the thing about SQL is, as the command is today, is that it represents something that's happening. We're taking a computer function and representing it in somewhat of an English statement. A select is an English word, right? That's basically why we're discussing the definition of SQL, because select is a word in a question. It represents a request. As we said before, query is a question or a request. Any query in SQL can be represented in simple English. So select star means everything from the artist tables. I put the word department, but that should, if we're querying a table that was called department instead of artist, that's what it would look like. So if we were to take this statement and represent it in normal English, in plain English, it just says, wow, I really messed up on this PowerPoint. But basically what I'm saying is if we were to represent what we did in normal English, it would be show me all the columns and all the rows from the artist table. And the output would look like the following. And so I've just taken all of our data here and put a few rows in the PowerPoint to show you how this is not really very useful, is it? Let's go back to SQL. I mean, you've probably looked at this and say, well, the tables look identical. What would be the function? And immediately there is not really a function. We're just getting started and we're executing the simplest SQL statement. But there might be a reason in which you want to list all the artists and all the information. So depending on what we're using this table for, this might be too much information. How do we get the output so that it's something more usable? Maybe we only want to look at 2 columns. So displaying specific columns, in order to create an output with only 2 columns, we use the following select command. Select artist ID and artist name from artist. So notice that I've replaced the asterisk, the star symbol, with the actual names of the columns from the table. In all SQL commands, the details that you type after each clause in the word have a specific purpose. So you want to be fluent, you want to understand SQL and type in the commands at ease without thinking of them. The key to being fluent in SQL is knowing exactly what kind of information is required following each of the clause words. Because after each clause word requires a different kind of information that you type after it. After the select clause, you always specify the columns that you want in the output. And after the from clause, you always indicate the table from which you want the data from, the source data. Wow, that's the end of the PowerPoint. But let's go back to SQL and look at their program again. So, sorry about this. Let's go back to the PowerPoint. So I went too far. Going back to the PowerPoint. No. Here we are. So we want to create a SQL statement that only has artist ID and artist name. Let's do that. Where is my SAS? So looking at our output, artist name, and then artist ID. We can take our asterisk and put artist underscore name. We use a comma to separate the field. Artist. Actually, I want ID first. And that's that. I'm just going to check with the output to make sure that I don't have any typing errors. When I type the word, when I type artist underscore ID, and artist name. So it looks good. Let's run it and hope there are no errors. Go back to the top. Hit run. Do you want to replace the results? Yes, I do. There we go. If I just want the artist names in every one of these fields, this is how I would do it. If I'm starting my job as a talent agent in this company and I just want to know all the names of the artists in the database, is exactly how I do it. So in the artist table that's sitting in the background in our database looks like this, has all this information. We don't necessarily want to look at it right away. You show up for day one. What are all the names of the artists? Maybe you've heard of them. Maybe you've seen them. Maybe you've worked for them in the past. So the first thing you would do is create your SQL statement and would create a report and output like this. And there we go. So that is actually the end. Thank you.